I would like actually know what's happening in this point. And then if my scheduled arrival is 9:00 and my aircraft arrived 9:05, 0:15, no 20, 10 o'clock, right? I would like to know why we were late. As a matter of fact, as far as I remember, some aviation authorities, they are including as a requirements on-time performance. Anyway, you know what? You can check what aviation authorities actually is doing this one. I'm not going to spend now too much time on this discussion. The next item, out of service. Let me explain. It's related to dispatch reliability. Here is dispatch reliability, right? Let's say we have 100% dispatch reliability. And then we have to always ask question. How many times we use the substitute aircraft to reach this, to achieve this 100% dispatch reliability? See what's happening here. Let's say we have 100 scheduled flight, 100 flights, right? Flights. If out of this 100, 10 times, right, we use substitute aircraft, then it's really and then, you know what, I'm not talking here, I'm not asking question now here from reliability, safety, aircraft economics perspective. Question here is even from resources perspective. See, if we have 10 aircraft and then we are using 10, 15 times this substitute aircraft, right? It means that actually we have actively 8, 9 aircraft, and then 1, 2 we have as a spare. So we need to understand all these models here now. How much actually we're paying for to have this type of level of dispatch reliability. Anyway, what else we have here? As I said, all metrics are in alphabetical order. AOG, PIREP, MIREPs, AOG is okay. AOG is here. Cancellation delay, MEL, NFF, MEL. By the way, I have here some interesting rates. Reset OK per PIREPs. It means that how many times we solve problems using reset OK. The pilot reported PIREPs, right? Again, same here, substitute aircraft to out of service, removals to PIREPs. We can continue this list. As I put here, what we need to track, we need to calculate to understand our technical reliability, business model, operation model, maintenance model, right? As I said, we don't want to build here some complex system. We need to understand what we want, why we want, and how we want to accomplish this. As I said, what is good for airline A does not automatically mean is good for airline B. We don't want to include all these MEL removals, troubleshooting in our report or even system. Now let's move to the next slide and see some examples. Examples also I put in alphabetical order, starting from constellations. We can have numerical numbers, right? Let's say in December we have 5 constellations, or we can use rates. Total constellation divides scheduled flight. Let's say total constellation is 3. Scheduled flight is 100. After calculation, we have 0.03. Now, as you can see, I highlighted this red mark here, right? By the way, next statement applies to mission interruption flights. Sometimes you can see the company uses in denominator instead of flight, scheduled flight, uses flight cycles. See what is the here problem? If we are using flight cycles, right, and scheduled flight is 100, after cancellation, we have 3 cancellations, right? Now, using flight cycles, it means that it's going to be not 100, it's going to be 97. I'm not saying that this is wrong or this is not wrong. What I'm saying that, as always we are saying, we need to understand what we want to calculate, what we want to see. If we want to assess the risk per flight cycles or flight hours, this is one story. But if we want to see how our system is performing, our model is set up, then this is a different story. Right? We have to be very careful what we are using, how we're using. Delay. Total delay divides scheduled flight, or we can use numerical. Again, some calculations here. Rate, let's say total delay we have 7. Scheduled flight we have 100. After calculation we have 0.07. Dispatch reliability, 1 minus initial delay plus initial cancellation divides scheduled departure, multiply 100%. Let's say, suppose we have here total delay 7, right? Initial is 5, excuse me. Total cancellation 3, initial is 2. So after calculation, we have 93%. Again, what I would like to mention, even as we said, right? We said this is kind of industry, in quotation marks, right? Standards. I added small limitation. You remember first case, 2 slides back, right? We didn't have any, we had just total delay, total cancellation. Here I'm saying initial delay, initial cancellation. Now if we are using here total, right? See, 5 plus 2 is 7, correct? If we are using total, 3 plus 7 is 10. Answer is 90%. So you can see even these type of very general metric formulas, we did it with small changes. And then it's very sensitive. It's very sensitive. Oh, we can say, hey, you know what? Okay, I have 5 aircraft. I don't care. Maybe you're right. But if you have 50, 100 aircraft, then again, not talking here about reliability and safety, right? But from resources perspective, you really need to think how you want, what you actually want to calculate. Engine in-flight shutdown. It's all about engine flight hours in denominator. Be careful here. Mission interruption flight partially covered, not repeating. MTBR, self-explanatory. Auto service. Sum of auto service time divide 24 hours, aircraft, multiply aircraft number, multiply days. Suppose we have 2 aircraft, same day we had a problem. Technical auto service. Aircraft number 1. Technical auto service 2 hours, aircraft number 2, technical auto service 3 hours. So divide 24 hours, right? Multiply by 2 aircraft number, multiply by 1 day, equals 0.104. And here again we have to ask question. Per what? And by the way, same question applies to piracy, right? See, I'm not going now to calculation here, what equals what, but we have 100 pirates, and the question should be per what? Is per 100 of pirates are per what? See what's happening here. We are saying per day, right? And then we are using here days 1. But if we put 365, or whatever days we have in here, then it becomes not per day but per year. 0.104 per year. So very small change, only one contributor, only one item he changed here, and completely different meaning. First case it was day, another case it is year. Same story here. Let's say 1,000 flight hours. We are saying no, we are using here 100 departures. So completely different meaning. We have to always ask this question, per what? substitute aircraft. Again, not spending too much time, self-explanatory. Mission interruption rate has added some limitations again. Unscheduled removal rates. As you can see, we are calculating two levels. We can actually have also this system level, but just again, I'm going to explain what the difference, okay? So, aircraft level, LRU level, unscheduled removal rates. As you can see, in denominator, we have flight hours. Or if we are calculating, depends on what we're calculating, right? We can use the flight cycles. But let's now stop on flight hours. So in both cases, denominator, aircraft level, flight hours, LRU level, flight hours. So what does it mean? Suppose in December we have 300 flight hours, aircraft flight hours. So these 300 in December goes here. Per aircraft, if we are calculating URR aircraft level. Now let's say we need to calculate URR per AC generators, and we have 2 AC generators. Now what does it mean here? It means that we have to multiply this by 2, this 300. And then in denominator now we have not 300 flight hours, but we have 600 flight hours. It's a little bit different, right? And last but not least, as kind of summary here, performance expression, standard rates. So we can use numerical number, as we said here, 5 for example, right? Statistics, percentage, right? Flight hour, flight cycles, 1000 flight hours, 100 departures, etc., etc. Time period, daily, weekly, monthly, 3 months, 6 months, 12 months, quarterly, total, etc., etc. And before we move to the sub-part 2, I would like to remind you that our airline operation/maintenance experience, not our competitors, not our neighbor airline, no, our own airline operation/maintenance experience defines our reliability system, reliability program, reliability metrics, formulas, performance standards, rates, etc., etc., etc. What is good for airline A does not automatically mean that it's going to be good for airline B. We need to understand what we are doing and why we are doing and how we are doing. Now let's move to the part 2 and see some reliability section examples.